The question 9 asks to show that if x1, x2 is a Markov chain, then it is statistically determined by its second-order probability basis. Pxi equals to xi and xj equals to xj for any ij to 1, 2, or etc. The definition of Markov chain assumes that the probability of a state transition at a certain moment only depends on its previous state, and assuming that the random variable at a time follows a probability distribution, it is called the initial state distribution. And because there is a conditional distribution between the random variable at a certain time and the random variable at a previous time, if it depends only on the previous one but not on the second one, the past random variable, this probability is called Markov property, and the random sequence with Markov probability is called Markov chain. And we can prove by that there is Px1 equals to xi and x2 equals to x2, and so on, still on to xn equals to xn. So it's equals to the probability that xn minus 1 equals to xn minus 1, and xn minus 2 equals to xn minus 2, and so on, based on xn equals to xn, and times the probability that xn minus 1 equals to xn minus 1, and so on. And by the derivation, we can finally get that the probability xi equals to xi is equals to the plus of xi equals to xi based on xj equals to k xj. So the probability that xi equals minus 1 equals to xi minus 1 is based on xi equals to xi is equals to the probability that xi equals to xi and xi minus 1 equals to xi minus 1 derivation, the probability that xi minus 1 equals to xi minus 1. And this formula is suits the problem that the Markov chain is statistically determined by the second order probability, which is the probability xi equals to xi and xj equals to xg.